In our demonstration, we found that if we have a coil of wire, we can induce a current in that wire, that is, create a current in the wire, if we move a magnet into the coil or take it out of the coil. Now, if we just leave it in the coil, we're not going to induce a current. The key is that we need to be changing the magnetic field through one of these loops. So we have to find which way is the current flowing. Notice how it switches direction. Sometimes it's that way, sometimes it's the other way. So how do you know which direction it's going to be? That's what we're going to find out. So we can use Lenz's law to help us. Lenz's law says the direction of the induced current, that's the current that's created in the wire, will oppose the change that created it. So what does this mean? Well, there's going to be a current in this wire, right? And whenever you have current in the wire, you also have a magnetic field, right? Current in a wire, a magnetic field is going to be produced. Okay, so the key is that magnetic field that's produced is going to oppose any change. So you take this magnet and you put it into the solenoid. You're pushing it to the right here. How do I oppose that change? Well, I oppose that change by making this my north end of the solenoid, right? I've got a north here, and if I want to oppose that change, I should repel. I should push it back, make it harder for you to put that magnet in. Now, think of it this the other way. If I want to take this magnet and I pull it out, how do I oppose that change? Well, I can oppose the change if I have a north end here and I'm pulling the north end away by creating a south end here. Right? These two are going to be attracted to one another. They're attracted to one another, and it's more difficult for me to pull that magnet out. Okay, so let's go back to our original scenario. We're taking this magnet and we're pushing it in. So how do I make that more difficult? Well, I have a north end here and a south end here. Okay. Now what's making this north end and what's this south end? Well, again, it's the current. Whenever you have a current through a wire, a magnetic field is produced. So how do I create my north end there and my south end using the current in this wire? Well, let's draw the magnetic field lines. It'll help us. So the magnetic field lines go from the north to the south outside. From the north to the south outside. Inside, magnetic field lines form a closed loop. So inside it's going to be keep going around in a circle. Okay. Now we have to use Ampere's right-hand rule to determine how to create that magnetic field. This is the magnetic field that's going to be created if I move this magnet in. Alright, how am I going to create that? Which direction do I need to put the current? So if you use your right-hand rule, right, we want to create circles that inside of our coil wire, we want our circles to be going to the left, and they curl around in circles so that inside it's to the left. Okay, now what you have to ask yourself, is it dot or X? You're going to have to use your right hand rule, and if you try it, you'll notice that if you put a dot here, your fingers will curl around in this direction. Similarly, if you put an X here, your fingers will curl around in this direction. So now we know the direction of our current. If I have dot and X, I can draw my dots on the bottom. My X is on the top. So what does that mean? That means the current must be moving at this point towards us, then away from us, and back down this way. So my current, again, let's do that one more time. At this point, it's towards us. Let's follow it. It's towards us. Now it's going away from us, and now it's going down in the wire. So let's just recap what we've talked about so far. So we can induce a current in a wire. What that means is this wire, there's no batteries attached to it. We can create a current in a wire if we change the magnetic field through that loop. If we just keep it still, if we don't move this magnet, we're not going to induce a current. That light bulb's not going to turn on. But if we move this magnet, change the magnetic field through that loop, we can induce a current. Now, to determine which direction the current is going, we have to use Lenz's law. Lenz's law says the direction of the induced current will oppose the change that created it. So if I take this magnet and I move it in to the right here, there's going to be a current in this loop of wire, and the direction of the current is going to oppose the change. So if I'm trying to push this in, how do I oppose the change? Well, I try to push it right back out. You repel. So how do I repel? If I have a north here, I can repel with a north here. So first you have to determine the direction of the magnetic field. Then when you've got the direction of the magnetic field, you use Ampere's law to determine which direction the current must be going to create that magnetic field.